Today I will be discussing the theory of strong duality in linear programming. Strong duality is a feature of linear programming that describes the relationship between a primal and dual pair of linear programs. Knowledge of weak duality tells us that it's possible for a pair of primal dual linear programs to both be optimal or for one to be infeasible and the other be unbounded, as represented by the table below. But is it possible for a primal LP to be optimal and the dual be infeasible, or vice versa? Also, can they both be infeasible? The strong duality theorem states that if both the primal and dual LPs are feasible and are finite, then both of them have a finite optimal value, and that the optimal values are the same. Therefore demonstrating that it is not possible for the primal to be optimal and the dual be infeasible, or the alternative, that the dual is optimal and the primal is infeasible. Both can remain infeasible, however, leading to only 4 possible outcomes as shown in the updated table. That both the primal and dual are optimal, that the primal is unbounded and the dual is infeasible, that the dual is unbounded and the primal is infeasible, or that both are infeasible. In other words, if x and y are the optimal solutions of the primal and the dual respectively, then Cx equals By, implying that the gap between the values of the primal and dual LPs is 0 if the solutions are feasible and bounded, unlike the weak duality theorem that implies that the gap between the primal has an optimal value smaller than or equal to the dual problem.